Good morning, everyone. Today we're doing Unit 4, Lesson 6, Trig Angles from 0 degrees to 360 degrees. So yesterday we began looking at these angles on the Cartesian plane from 0 to 360 degrees, and today we're going to continue exploring those and discuss how they relate to those primary trigonometric ratios, so sine, cosine, and tangent. All right, so for any rotation angle theta, so that Greek letter that you see often in math, especially for trig, is pronounced theta, in standard position and has a point P made up of the coordinates x and y on its terminal arm. The primary trigonometric ratios for the angles are, so we're first going to label this triangle with our side length. So if our point, the coordinate of our point is xy, right, that's how we get to our point, then the side lengths of our triangle are made up of that point. So this is x, the horizontal part of my triangle, right, because that's the horizontal axis, and then the vertical part of my triangle, the vertical leg, is y. So the sides of our triangle are x, y, and the hypotenuse is r. So we're going to keep that in mind when we go to identify our trig ratio. So if we were to say the sine of theta, well, we know the sine of theta is opposite over our hypotenuse. So the sine of theta is going to be y over r. Now our cosine is adjacent over hypotenuse, so let's go ahead and label that other side. So this would be our adjacent side of our theta. So the cosine of theta would be x over r. And finally, the tangent of theta is opposite over adjacent, which is y over x. Okay, and something to recall in terms of right triangles is that we can find any missing side using Pythagorean theorem. So if we wanted to, for instance, find out what's r, so if we were trying to figure out what is r, we could rearrange Pythagorean theorem for r, and that would end up looking like that. So r is equal to the square root of x squared plus y squared. So recall Pythagorean theorem is a squared plus b squared equals c squared. So if we wanted to plug in those values we know for our side lengths and our hypotenuse, we would say x squared plus y squared equals r squared. And then we would subtract, or we already have it all subtracted, so we just have to take the square root of both sides. We already have it isolated for r squared, so we'll just take the square root of both sides. So x squared plus y squared equals r. So that's where that r comes from in terms of x and y values. All right, so we're going to look at some examples of theta on the Cartesian plane. Might be in quadrant 1, might be in some of those other quadrants. Let's remember where our quadrants are, though. So our quadrant 1 starts there where x and y are positive, and then we move in a counterclockwise rotation for those quadrants. Okay? All right, so the coordinates of a point on the terminal arm of an angle theta in standard position are g, -3, -5. So let's just plot that point, just a guess. So we're going to say 1, 2, 3, 1, 2, 3, 4, 5. So we'll plot a point for g. Okay, and we're going to connect that point to a terminal arm. So we're going to make our terminal arm like we have been with all these angles. All right, and we're going to create that terminal arm, or make that terminal arm into a triangle. Let's try that again. All right, so that should connect right at 3. All right, and we're going to have the base of our triangle be along the x-axis, and we'll have theta be inside that triangle. So we're going to label those side lengths of the triangle, or at least what we know. We know that our x value is a -3. So this side of my triangle is -3, and this side of my triangle is a -5. It says determine the exact primary trigonometric ratios, so that means we are looking to find sine, cosine, and the tangent of theta. So we first need to figure out, well, what's r? All right, remember, r, we use r for this because that's basically the radius of this circle. If we were to draw a circle around our Cartesian plane, which we call our unit circle, then that would be represented as the radius. So that's why we represent our hypotenuse with an R. So pause the video and go ahead and figure out what R is, and then identify your sine, cosine, and tangent of that theta. So there's the solutions for your primary trig ratio. So we first have to find our R value, or our hypotenuse. So we'll plug our X and Y into the formula, and we should find that R is equal to the square root, or the radical of 34. We're going to leave it as a radical because we want it to be an exact value. As soon as you take the square root of a number that's not a perfect square, then you're rounding it. So we're going to leave it as a square root. So now we can identify our sine, cosine, and tangent. Something to make note of too is when you have a negative, make sure that that negative comes through when you write your primary trig ratios. So our sine of theta is going to be a negative 5 over radical 34. Our cosine is our adjacent side, which is a negative 3 over our hypotenuse of radical 34. And then lastly, our tangent is opposite over adjacent, which is a negative 5 over a negative 3. And a negative over a negative is going to become a positive 5/3. Okay, so we'll continue looking at some examples. One of the primary trigonometric ratios for an angle is given, as well as the quadrant in which the terminal arm lies. Determine the other two primary trig ratios, give exact answers. So again, any radicals we get for these examples, we're going to leave the radicals. So we're going to try one together, and then I'm going to get you guys to do one on your own. So this says in quadrant 2 we have theta. So let's start by drawing theta in quadrant 2. So we're going to have some angle created, and it's going to be in quadrant 2, which is over here. So I'm going to draw my terminal arm in quadrant 2, and I'm going to make my theta between that terminal arm and always the x-axis. So now I'm going to turn that terminal arm into a triangle so that we can label some of our side lengths. Okay, so cosine, think cosine is adjacent over hypotenuse. So that's where these are going to go. And we have to think about, well, where will the negative go? Looking at our triangle, which value is going to be negative, our x or our y? And if cosine is adjacent, well, my side adjacent to my theta is along my x-axis. So we'd say that this is 6, and this is negative x value. So this is where my negative goes, is on this part. And then it's over our hypotenuse. So my adjacent is here. My hypotenuse is always across from my right angle. So now we just have to figure out, well, what's y, so that we can identify those other primary trig ratios. So we will say that negative 6 squared plus y squared equals 10 squared. So we'll just simplify where we can, and then we'll subtract 36 from both sides. And finally, we'll take the square root of both sides. So you'll have y is equal to 8. Okay, so now we can identify our other ratios. So the sine of theta, well, we've now calculated what that side length is going to be. We know that y is equal to 8. So that's my opposite side. And again, it should be a positive y because we're moving in a positive direction there. So my opposite side is 8, and my hypotenuse is 10. Tangent of theta is going to be our opposite side, which is 8, over our adjacent side, which is a negative 6. Okay, and usually when we write a negative in a fraction, we either put it on top or in front of the fraction like that. Okay. So I'm going to draw that second one for you, and then I'd like you guys to continue on with this. This should be a positive 4/5. That's just a typo in the note, so sorry about that. That tangent theta should be a positive 4/5. So if we're in quadrant 1, let's draw that. Theta is going to be in quadrant 1. We're going to draw our terminal arm somewhere in quadrant 1, and we'll put theta there, and then we're going to turn that terminal arm into a triangle. So remember, tangent is opposite over adjacent. So from my theta, the opposite side would be this leg over here, and my adjacent side would be along the x-axis there. Okay, so now we know two sides, but in order to do all of our primary trig ratios, we need to identify that third side, which is r. So go ahead and pause the video and finish working through this one, identifying the other two trig ratios, and then try that third example with the sine theta in quadrant 4. So there are the solutions for the next two examples. We determined what r was with our tangent ratio equal to 4/5, and we found that r is radical 41 when we plugged into our Pythagorean theorem. And then from there we found our sine ratio, our opposite side of theta is 4 over our hypotenuse, which is radical 41. And our cosine theta is equal to the adjacent side of theta, which is 5 over our hypotenuse, which is radical 41. This third example here, so our trig ratio is in quadrant 4. So I wanted to draw my terminal arm in quadrant 4, which we did here, okay? And then we're gonna connect that back to our x-axis to make a triangle. And then we have to think about that sine is opposite over hypotenuse, so that's where I'm gonna label these fractions on the triangle. So my opposite side is the -7 and my hypotenuse is radical 58. And then again, we plug into Pythagorean theorem to find the other side length of my triangle and find that it's 3. And then go through finding your cosine of theta and your tangent of theta. Okay, so now we're gonna kind of look at some special triangles that we've used in other lessons, the last lesson in particular. So if we're given an angle, we should be able to boil that down to one of our special triangles to determine those primary trig ratios. So if we're given angle A is equal to 210 degrees, if we draw that on our Cartesian plane, we should be able to see which quadrant we end up falling in and then go from there. So if we draw 210 degrees, remember it's a positive. So we're gonna go in a counterclockwise direction, 90, 180, 210 is gonna be somewhere in quadrant 3. So this is angle A, and it's 210 degrees. All right, now if we wanna make a triangle again out of this terminal arm, we need to know what is that related acute angle or that reference angle, because that's gonna be my theta. So when we're in quadrant 3, theta, or a related acute angle, is going to be equal to our principal angle minus 180. So theta is going to be 30 degrees. Okay, so we have a 30-degree angle there. This angle is going to be 60 degrees. Let's just write, this is going to be 30 degrees. Okay, so we have a 30, 60, 90 triangle. We should be able to label that. We should know that special triangle. So we know this side is 1, this side is radical 3, and the hypotenuse is 2. But that's for a special triangle in quadrant 1. We're in quadrant 3. So yes, those are my side lengths, but we need to look at them and say, okay, which ones are going to be negative? Well, my x is in a negative, along the negative x-axis, and my y is also going negative. So that's going to be negative as well. So now that I've identified my negatives, my hypotenuse is always going to be positive. We can identify our ratios. So the sine of theta is going to be my opposite side over my hypotenuse, which is a -1/2. Cosine of theta is going to be your adjacent side, which is a negative radical 3 over your hypotenuse. And the tangent is going to be our opposite side over our adjacent side, which is a -1 over negative radical 3. I wrote too many negatives in there. So if you have a negative over a negative, that makes it positive. Okay. I'm going to pause the video. You guys see if you can draw 315 degrees on your Cartesian plane and then figure out your related acute angle and what special triangle it is. So there's the solution for the next one. If we were to draw 315 degrees, we should end up in quadrant 4. Okay, and if we determine our related acute angle, so the distance from our terminal arm to the x-axis is going to be 45 degrees. So then we know we're dealing with a 45, 45, 90 triangle, and we can label the side lengths. The legs are 1, 1, and the hypotenuse is 2. But one of the legs is going to be -1 because of the quadrant that we're in. So once we have those legs, we can identify all of our primary trig ratios. So the sine of theta, our opposite side is that -1 over radical 2. Our cosine of theta, our adjacent side, is a +1 over our hypotenuse of radical 2. And then finally, our tangent of theta is our opposite side, which is a -1, over our adjacent side, which is a +1. So a -1 over +1 is a -1. that is it for your notes for today.